So back to 11b, we're trying to find the part that's missing, and I want to point out, yes, it's a right triangle, so Pythagorean theorem or trigonometry could be used, but the thing we're finding is an angle. Pythagorean theorem doesn't find you angles, so we will need to use trigonometry. If this is my right angle, then 20 is my hypotenuse, and across the triangle from my angle makes this across from, or the opposite side. The one right next to my angle is the adjacent leg, and it's the one that's not labeled. So SOHCAHTOA tells me we're going to use a sine ratio. So you always write sine of your angle. My angle is x. You set it equal to the ratio SOHCAHTOA of O over H. 10 over 20. So then you got to get x by itself. Cross multiplying is not helpful because you almost have x by itself. You just got to get rid of the sine. To get rid of the sine, I'm going to take sine inverse of both sides. So that'll cancel. And then I can say x is found by taking sine inverse of that fraction 10 over 20. So I got to go to my calculator and put that in. See if I can effectively show my calculator. So if I'm trying to use my phone's calculator, I'd have to do 10 divided by 20, get that decimal, and then say sine inverse, which means I need to push second and then sine. It's getting me 30, which is the exact same thing I get on my calculator. If we can turn it so we can actually see. So I'm going to push second sine and then 10 divided by 20. Both of them give me 30. So that's the angle measurement for x. We didn't have to round on this one. It was just exactly 30 degrees. And then the last one, part D, another right triangle. But this time x is a side length. But you can't use Pythagorean theorem because there are two sides I don't know. And if there are two that I don't know, Pythagorean theorem is not helpful. So I'm going to start by identifying my hypotenuse. I did give you an acute angle. So across the triangle from that acute angle is the opposite leg. Next to that one is the adjacent leg. So you'll notice the opposite leg's not needed here. It's just the hypotenuse and the adjacent leg. So SOHCAHTOA tells me this is going to be a cosine ratio. So after we write cosine, we always write the angle. That last example had a variable, a letter for the angle. Here we actually get a number. But you'll still set it equal to a fraction. And that fraction is the adjacent leg over the hypotenuse. So in this case, you're not finding an angle. If I take cosine inverse right now, it's going to make a huge mess because I'll have to do it to this side. It's not going to cancel. Not what I want to do. Cosine inverse is for finding angles. When x is somewhere in your fraction, you are going to want to cross multiply. So I'm going to put it over 1, and I'm going to do x times 1 and set it equal to the product of 16 times the cosine of 37 degrees. That's what I need to put in my calculator. It's already solved. You don't have to divide. We just need 16 multiplied by the cosine of 37. So let's go back to my calculator. So for this one, I want 16 times, now I have to put this one in backwards, 37. And I need to be careful. This one's still trying to do cosine inverse. I don't want cosine inverse. I want regular cosine. So the product of 16 and the cosine of that is about 12.8-ish. Or I could do it with my other calculator. So 16 times the cosine, I think it was 37, 12.8. So that is our approximate length for x. So on these last four here, none of them used Pythagorean theorem, but you need to be aware that sometimes you do. Sometimes like a problem like this, you just need to know another side of a right triangle. Pythagorean theorem still does show up sometimes. But then the main thing to keep in mind is when do I do inverse and when do I cross multiply? Again, inverse is for angles. when you are finding an angle like we did here, you can see our final step used an inverse. However, if you're not finding angles, when you're finding side lengths and you can't use Pythagorean theorem, that's when you'll see both times here and here we cross multiplied. Now, when you cross multiply, you still have to solve the equation. Sometimes it's pretty quick, like this last one. Other times, after you cross multiply, you'll still have to solve by division. So just pay really close attention. It's not a one-size-fits-all. You do have to be really careful for the solving process. So last note I'll put on here is when you cross multiply, it's in order to find side lengths. Let's go for sides.